What up YouTube, it's your boy Learn Things Have Fun coming at you again live and direct with another YouTube video. This time, we are jumping into the beautiful world of surds. Okay, simplifying them, rationalising denominators. We're going to kick off with simplifying, then we're going to work our way to rationalising, all good fun. Alright, let's have a look at these numbers, okay? Now, this says square root 4, but what does square root 4 even mean? Let's expand our brains. The answer to this square root will be a, okay? And we are now looking for a number where a times by a equals 4. That is the operation of that square root. Now, what is this number a going to be? A times a equaling 4, it's going to be 2, okay? We know that 2 times 2 equals 4. So the answer to this square root here will be 2. Let's evaluate this square root 16. Let's call this one b. So we're looking for a number b where b times by b gives us 16. Have a think? Yes. Okay, it's going to be 4. So 4 times 4 equals 16, so square root 16 is 4. With cube root, we're taking the same sort of approach. So let's have a look at this one. We'll call this a as well, where a times by a gives us 27. What is this going to be? A times a equals 27. Well, I think a is going to be 3, because 3 times 3 times 3 times 3 is 9, times 3 is 27. So cube root of 27 is 3. Last but not least, the fourth root of 16. Good golly, man. We'll call this b. So we're looking for a number this time where b times b times b times b equals 16. Have a think what that could be. What that could be. Well, it's going to be 2, okay? 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the cube root of 16 is 2. This is all neat and lovely. So we can have our square roots, our cube roots, our fourth roots, our fifth roots, our 10th roots, and we can get rid of all of them. But, hang on, oh dear. Let me just drop this down so that we don't have a too busy slide there. Trouble ensues. Trouble in paradise, trouble ensues. Square root 17. We are looking for a number, a times a, which equals 17. Try and think of that number. A times a equaling 17. It's not 4, because 4 times 4 is 16. It's not 5, because 5 times 5 is 25. So it's going to be somewhere between 4 and 5. Okay? It's not going to be a nice number. Actually, what it is something called an irrational number. So I've loaded it up on the old calculator, and we see that it is 4.123105626. That's not the end of the number. This number never reaches a terminus. It never cuts off. It continues going forever. We can continue this calculation onwards. That means if I replace this surd with a decimal, I'll be losing accuracy. Say I rounded it to a couple of decimal places and I called it 4.12, and I did a whole onwards calculation where I used this 100 times, say it was some advanced computation. Okay, I would have lost all the accuracy of all these missing decimals. Okay, so we want to leave it as in this square root form. So we'll call this a surd. This is a surd. So it's a number left in the square root form. Now there are a couple of rules that can help us manipulate surds and basically have a nicer time with surds. So let's have a look at these now. Okay, so we have this multiplication rule, okay? If I have two numbers, a and b, surds rule, by the way, square root of a times b equals square root of a multiplied by square root of b, and this is the quotient rule. Square root of a divided by b equals square root of a divided by square root of b. We'll explore these both now. Okay, first we're going to take a quick detour. Okay, so you may have noticed that all of these numbers had very nice solutions. Okay, generally if we go with, well, all the time, if we go with these square numbers, they're going to have very nice solutions when they're square rooted. Okay, we reach the square numbers by squaring each number on the number line. So the first square number is 1 times 1 is 1. The second square number is 2 times 2, which is 4. The third square number is 3 times 3, which is 9. The fourth square number is 4 times 4, which is 16. The fifth square number is 5 times 5 is 25. The sixth square number is 6 times 6, which is 36. The seventh square number is 7 times 7, which is 49. Okay? What we're going to do is we're going to keep an eye for these square numbers, and we're going to see if we can spot them, okay, as factors of the number that is being square rooted. Allow me to demonstrate. I see that this is square root 20. I'm going to do a cunning rewrite of square root 20 in order to simplify it. I'm going to call this instead square root 4, which is my square number over here, multiplied by 5. Ooh, square root 4 multiplied by square root 5. This becomes exactly that I just muttered there, square root 4 multiplied by square root 5 by the multiplication rule. But now let's have a think. I'm looking in this first square root here for a number, a times a, which gives me 4. I know that 4 is a square number, okay, so I know 2 times 2 gives me 4. So I know this is going to be 2 root 5, okay? So let's recap what just happened. By breaking down the number being square rooted into a square number being multiplied by another number, I was able to split up this surd via the multiplication rule and thereby simplify it. Let's try it over here. Okay, so square root 20, kind of the same sort of deal here. So 4 times 5 over 2, which is square root 4 times square root 5 by the multiplication rule over 2, which is 2 root 5 over 2. The 2's are a common factor and cancel, leaving us root 5. Look how much neater that is. Come on. Okay, let's see what we can do with these. So, 5 root 6, I don't think we can do much with. Have a think about what square numbers you can spot in root 24. Do any of these square numbers jump out to you as a factor of 24? Think. Well, I see that's going to be 4 times by 6, okay, plus, oh good golly, what's there? 49 maybe, hang on, 294 divided by 49 is 6, yes, so that's going to be square root 6 times 49. Let's keep rewriting this. So I have 5 root 6 minus 2 root 4 root 6 plus root 49 root 6. Okay, I can now perform these square roots. So that's 5 root 6, let me just give myself some more room. 5 root 6 minus 2 times 2 root 6 plus 7 root 6. So that's 5 root 6 minus 4 root 6 plus 7 root 6. 5 minus 4 is 1. 7 root 6 plus 1 root 6 is 8 root 6. Okay, so we did some simplification. So all I'm going to do now is I'm going to jump in and do a little bit of practice. Okay, for each one of these, pause, have a go, and then watch my solution. Okay, so with this one, I'm going to fire up the quotient rule. So with the quotient rule, we know that this is equivalent, okay? So the surd divided by a surd is the same as the square root of the fraction of the two numbers being square rooted. So 44 divided by 11 is just 4. 11 goes into 44 4 times, so that's just 2. So that's a nice one. With this one, we've got to firstly expand the old double brackets, and we're going to use the firework method. So I'm going to draw a beautiful firework. I'm going to multiply everything that the ends of the firework touch. So that's going to be 2 times 3, which is 6. I'm going to follow this next root of the firework this way. So that's going to be minus 2 root 7. I'm going to follow this one, so that's minus 3 root 3. And then I'm going to follow this one, so that's going to be plus square root 3 times 7. Well, first... Okay, so we've expanded and we've multiplied. These actually can't be simplified any further. All of these surds can't be massaged in any way to link them together. So this is as simple as that expansion can get. So let's have a look at this one. We're going to look and we're going to see if we can spot any square numbers within these numbers being square rooted. So have a think. Well, I think this is going to be square root 25 times 3, and this is going to be square root 4 times 3. Okay, so that becomes square root 25 times square root 3 minus square root 4 square root 3. So this becomes 5 root 3 minus 2 root 3, which equals 3 root 3. Okay, we're going to move on and we're going to look at rationalising a denominator. So we may want to remove surds from the denominator of a fraction. There are 3 methods that we're going to apply, and each will achieve this same goal. We're going to look at these 3 different forms, which are the 3 different forms that we're likely to encounter. In the first instance, we just have a surd alone in the denominator. And in this case, I'm simply going to multiply top and bottom by that same surd. So if I had 1 over a, I would multiply by root a over root a. In form 2 and 3, they're very similar. So with this first form, I have 1 over a plus square root b, and I multiply top and bottom by a minus square root b. And in the other case, I have a minus square root b, and we'd be able to remove the surd from the denominator by multiplying by a plus square root b. So it's essentially just a case of flipping this middle sign. These are the rules. Make a copy of them down if you've not already got them in your notes, and let's just have a go at applying these. Okay, so it's fairly straightforward here. So with this one, I'm going to apply rule number 1. I've got surd by itself, so square root 3 over square root 3. This becomes on the top 1 times square root 3 is square root 3. On the bottom, I have square root 3 times my square root 3, which is of course the same as square root 3 over 3. Square root times square root cancels itself out. Okay, so here we go. We have now no surd on the denominator. Happy days. Let's have a look at this one. 1 over 3 plus square root 2. Right, well, I want to multiply top and bottom by the conjugate. So I'm going to go 3 minus square root 2 over 3 minus square root 2. Okay, this is going to equal 1 times 3 minus square root 2. Well, that's fairly straightforward. That's going to be 3 minus square root 2. On this bottom, I'm going to have to do a little bit of a firework method. I've got 3 plus square root 2, 3 minus square root 2. I'm going to draw my beautiful firework. I'm going to follow the lines of that firework and multiply everything that touches. So this is going to be over 3 times 3 in this first instance is 9. I'm following the second root now, so it's going to be minus 3 root 2. I'm now following this one on the bottom here, so that's going to be plus 3 root 2. And finally, I've got minus square root 2 square root 2. So if we look at this fraction here, we see these 2 cancel, and I have 9 minus square root 2 times square root 2 is just 2. So that's my final answer will be 3 minus square root 2 over 9 minus 2 is 7. There you go. And look, no surds in the denominator. How lovely. Let's have a look at this one. Okay, this time the conjugate, remember we're looking at the conjugate by swapping the sign on the bottom. Okay, so we're going to swap the sign of the bottom selection of surds here. So we're going to multiply top and bottom by 5 plus root 2, root 5 plus root 2, and 5 root 5 plus root 2 at the top. So similar sort of thing, what I have to do now is I'm going to have to do a firework method for the top and the bottom, so let's do that. So here I have root 5 plus root 2, multiplying root 5 plus root 2. And we're going to just quickly draw our firework. We're going to follow the lines. Did not want that. Thank you, auto draw. So that's going to be root 5 times root 5 is 5, plus root 5 times root 2, which is going to be root 10, plus root 5 times root 2, which is going to be root 10. And then we have root 2 root 2, which is plus 2. So this is going to be, eventually that's going to equal 7 plus 2 root 10. And then for the denominator, so I have root 5 minus root 2, multiplying root 5 plus root 2. I'm going to draw my firework. Here we go, lovely, lovely. And we're following the lines of each part of the firework, and we're multiplying the things that touch. So root 5 times root 5 is going to be 5, plus root 5 times root 2, so we just call that square root 10, minus square root 10, that was the minus square root 2 times root 5, and last but not least, minus root 2 times by root 2 is going to just be 2. So on my denominator there, I have the 2 root 10s cancelling, 5 minus 2 is 3. So there we have it. Again, we have no surds in the denominator, exactly according to plan. Last couple of examples, I think, here we go. 1 minus root 3 squared is our denominator. In this case, we're going to firstly have to do a little bit of algebra to get into one of the forms that we're used to seeing. Okay, so to start with, before I do anything else, I'm just going to expand that squared on my denominator. So I'm going to go 1 minus root 3, 1 minus square root 3. I'm just going to expand this first. So I'm going to do my lovely firework method. So it's going to be 1 minus square root 3 minus square root 3 plus 3. So this denominator I'm going to rewrite as, so my numerator stays the same as 1. My denominator is going to be 4 minus 2 root 3. I just collected the like terms there. Now that we're here, okay, we can actually apply our normal rules to rationalise this denominator. I'm just going to multiply top and bottom by the conjugate of 4 minus 2 root 3. Okay, so that's going to be multiplied by 4 plus 2 root 3 over 4 plus 2 root 3. Numerator is easy peasy, that's 1 times 4 plus 2 root 3, which is 4 plus 2 root 3. On the denominator, I'm going to draw that out more neatly, so I'll have 4 minus 2 root 3, multiplying 4, oops, that's not 4, 4 plus 2 root 3. I'm going to draw my firework, so here we go, and we're going to multiply everything that touches, and I'm going to write that out over here. Okay, so 4 times 4 is 16, 4 times 2 root 3 is going to be plus 8 root 3, minus 2 root 3 times 4 is going to be minus 8 square root 3, so that is a 3 there. And last but not least, we're going to have minus 2 times 2 times root 3 times root 3, so 2 times 2 times by root 3, and let's simplify that. So these two cancel, plus 8 root 3 minus 8 root 3. On the numerator, I'm still going to have 4 plus 2 root 3, all over 16 minus root 3 times root 3 is just 3, so this becomes 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. So my denominator becomes 4, and my numerator remains 4 plus 2 root 3. I can actually pull out a common factor there, so I can say 2 multiplies 2 plus root 3, divided by 2 multiplies 2. The 2's cancel, and that becomes 2 plus root 3 over 2. Does that make sense? Yes, I think it does, more or less. Okay, here we go. So, practice time. Feel free, have a go at these before I try them. Pause the video, or just watch me do it. No more new skills from this point onwards, we're just cranking the handle on what we've already learned. So let's have a look at this. All we're doing is we're just doing more of the same, figuring it out. All good, right, okay. So, this first case, root 7 divided by root 63, I'm going to multiply by root 63 over square root 63. Okay, My answer is going to be square root 7 times 63 over 63. I'm just going to jump in my calculator and just work that one out. So square root 7 times 63, is that a nice number? It is, good, 21. So it's going to be root 20, sorry, just 21 over 63. 21 over 63, I'm thinking there's some common factors there. 21 divided by 63 is 1/3. Happy days. So that's 1 over 3. Let's look at this next one. Here we go. 2 minus root 3 over root 3 minus 2. I'm going to multiply by the conjugate of the denominator. Okay, so I'm going to multiply by root 3 plus root 2. Oops, excuse me, that was a weird root 2. Over root 3 plus root 2. Okay, so I'm just going to take each case individually so that it's a little bit easier to keep track of what's going on. So that's going to be root 2 minus root 3 multiplied by root 3 plus root 2. That's the numerator there. So let's draw a firework. Here's another firework. You don't even have to draw a firework every time, I'm just doing it because it's a bit more visual. So that's going to be square root 6. 2 times 3, plus square root 4, which we know is 2, but we'll just keep going with that, minus square root 3, so I'm just going to call that minus 3, and then minus square root 3 times 2, which is 6. Let's just neaten that up a little bit. So these two cancel. Square root 2 is 2, so it's going to be 2 minus 3, so my numerator is going to be minus 1. Okay, let's look at the denominator. Let's write this one out over here. So I have square root 3 minus square root 2, multiplying square root 3 plus root 2. I'm going to draw my firework. That was a beautiful firework. Look at this firework go. Right, square root 3 times square root 3, we're just going to call that 3 straight away, plus root 6, minus root 6, that's good, minus root 2 times root 2 is just 2, so that's 2. So we have cancels, 3 minus 2 is 1, 1, so my numerator is minus 1, my denominator is 1, so the answer is minus 1. Happy days. Right, last two I believe, so we're nearly there, good job if you're still watching. With this one, again, we're going to do the algebra first and crank the handle to get this into one of the three forms that we've seen so that we can apply our usual methods to rationalise the denominator. So as a first step, before I do anything else, I'm going to expand the double brackets on the bottom here. Okay, so we're going to just rewrite these out over here, so 5 minus square root 3 multiplies 2 plus square root 3. I'm going to draw my firework. Ba-bang, 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 ba-bang. Did not want that all to draw, how dare you. Right, let's look at these answers here. So 5 times 2 is 10, quick maths. 5 times root 3 is plus 5 root 3, minus 2 root 3, minus 3. So that's going to be 7 plus 3 root 3. Yes, it's 10 minus 3 is 7, 5 root 3 minus 2 root 3 is 3 root 3. Okay, fine. So we have instead, this is actually equivalent to 2 over 7 plus 3 root 3. Now we've got it into our normal form, we can just multiply by conjugate. So what I'm going to do is I'm going to multiply by 7 minus 3 root 3. I'll just swap the sign there, 7 minus 3 root 3. And now what I have to do is crank the handle and find the answer. So in the numerator case, we've got 2 multiplies 7 minus 3 root 3, which becomes 14 minus 6 root 3. In the case of the denominator, let's do that somewhere here. So 7 plus 3 root 3, 7 minus 3 root 3. I'm not even going to draw the firework this time because we're so good at this. We've learned together. Look at our skills. Look at how we're doing at maths. Good for us. Good for you. 7 times 7 is 49. Minus 7, 14, 21 root 3, doesn't matter, it's going to cancel in a second anyway, plus 21 root 3, and then we've got minus 3 times root 3 times by root 3, okay? These two go, bang bang. Root 3 times root 3 is obviously 3, so over here I have 3 times 3 times 3, so I have 49 minus 27, good golly man, right, 49 minus 27 is 22, for Taylor Swift. So my denominator is 22, my numerator is 14 minus 6 root 3, yes, so my total answer is 14 minus 6 root 3 over 22. And I think there's a common factor there, so we can go 2 times 7 minus 3 root 3 over 2 times 11. So my final answer is going to be 7 minus 3 root 3 over 11. I think that's fully simplified because 11 is a prime number. Last one, here we go. Rewrite this in the form p plus q root 5, where p, q are constants to be found. All they've done is they've dressed up our usual business in slightly more elaborate words. Don't be scared by the problem solving, we're doing the exact same normal thing. The only change I'm going to make to this form is I'm going to rewrite this as 3 minus 2 root 5 over minus 1 plus square root 5. Okay, just so we're in that normal form that we've seen. These are two exact equivalents. This is plus root 5 minus 1 plus root 5 is the same thing. In this case now, I can multiply by the conjugate. Okay, it's going to be minus 1 minus square root 5 over minus 1 minus square root 5. Let's deal with the numerator first. So I have 3 minus 2 root 5 multiplying minus 1 minus square root 5. Okay, let's draw a firework here, 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 here. Let's follow the lines of each part of the firework and let's multiply through. So it's going to be minus 3 minus 3 root 5 plus 2 root 5 plus 2 root 5 root 5. So 2 multiplies root 5 root 5. Root 5, root 5. Let's just see what happens here. So I've got minus 3, minus 1 root 5, and then I've got 2 times 5, which is plus 10. So that's going to be 7 minus root 5. That's our numerator. So let's draw that over here. So 7 minus square root 5. Let's get some space so we can look at the denominator. So I've got minus 1 plus, plus
Hello Dream Team, so it appears that my camera ran out of recording battery there. Still definitely new to the YouTube game, but hopefully that gave you a little insight into surds, simplifying them, rationalising denominators. Let me know if that helped. As always, smash like, smash subscribe. Building a community here. What do you want to see from the A-level maths or A-level physics? What do you want to learn? Yeah, smash like. Peace.